Hi everyone, and welcome to the second episode of this beginner's programming tutorial. In this episode, we will learn about variables, what they are, what we use them for, and how to make them. Variables are used in programming to store information for later use. We keep the values safe so that at a later stage we can manipulate it in some way, for example by outputting it, or by performing some other kind of operation. To explain variables, I would like to make a comparison. Your computer's memory will be represented by this large cabinet with an enormous amount of unmarked drawers in there. Of course, more than we can see in this picture. Now, when we tell the computer to make a new variable, the computer wants to know two things before it can store information inside of that variable or inside of that drawer. What kind of data does this store, and what name should I file this information under? So every time we make a new variable, we need to tell the computer the so-called data type and name of the variable. For most of this series, we will be using the following four data types. Int, or an integer for long, for storing whole numbers. For example, 1, 1023, and minus 2094. An example would be your age, which is often referred to in whole numbers. Floating point number, or float for short, for storing decimal point numbers, for example 0.1, 3.141592, and something like minus 10.53. An example would be a length, like 1.5 meters tall. The next data type is Boolean, which is used for storing true or false values. It can only hold either true or false, and it's often used to act like a switch. The next data type is string. This stores a literal text between double quotation marks. The hello world text from the previous episode was a string. It just was never stored inside of a variable. So, as an example, let's say we want to store someone's name. This is a piece of text, so the data type should be string. We also have to tell the computer what name to give the variable. You can be as creative as you want, but always remember that it will be helpful in the long run to use clear and informative variable names. I'm going to pick the name for this variable. Putting this together, the computer now takes a drawer from the cabinet, puts a label with name on it, and makes sure only strings can actually go in it. If we then assign a value to the variable, that value will be stored in this drawer as long as it's a string. Now it is time to put this theory into practice. First, let's open processing, as we've done in the first episode. So we open the folder and double-click the executable. Next, in the code editor, we want to recreate the example I just explained. We want to store a name. So, first we need to tell the computer what data type we want to store. In our case, this is a string. Secondly, we need to tell the computer what name we want to give this variable. In our case, this is name. Now this is not a valid variable. We've declared the variable, we just haven't put any value inside of it. To put a value inside of a variable, you use what's called the assignment operator, or simply put, a single equal sign. To store the value John Doe inside of the variable we just created, we make a new line, put the name of the variable we want to change, and add the equal sign and the literal text John Doe between quotation marks. Now we once again finish with a semicolon. To visualize that the value of the variable has indeed been assigned, we can use the println function. So we make a new line, add println function, and between the parentheses we put the name of the variable we want to output. Whatever we want to output should be between the parentheses, and last time this was a literal string, hello world, but you can also put any variable name here, and then the computer will look up the value of that variable and output it. Also, don't forget your semicolons after every command. If we run this code, you'll see the value John Doe as output in the console. You can also try to change this assignment. For example, if you do another assignment, the first assignment is overwritten like this. We add another line, once again, the name of the variable we want to change, the assignment operator, the single equal sign, and we add, once again, a literal text, Jane Doe. Now we close off with a semicolon, and now John Doe is overwritten by Jane Doe, as you can see if we run this example. Now without changing anything in the print line, you see the output has changed. The computer still looks up the same variable to output to the console, but this time there's a different value in there. If you remember earlier in this episode, I told you about the 4 data types we will be using most commonly. Let's make one variable for each. First, an integer, a whole number. The data type is just int, and we need to give a good name. We want to store age in it, so let's name it, quite originally, age. Then we store 100 in it, which may or may not be my actual age. But this time, you see, we can actually do it all in one line. You see, programs are lazy. If there's something we do a lot, we want to make it easier, faster, and or shorter. We make a lot of variables and immediately give them values. Let's do that in one line. So now let's repeat this for a floating point number, in which we will store a floating point number, my length, 1.79. First, type the data type, then the name, appropriately length, and then, immediately on the same line, we assign the value, 1.79, and we end once again with a semicolon. The last data type we will talk about today is a boolean, and I will store in this boolean whether I had coffee today, so I will name it had coffee. The data type is boolean, so I'll type that first, and then I'll type my name, had coffee, and assign the value true. Now, this might seem a bit hard to visualize, but we can print line all of them. If we print line age, it'll show 100. If we print line length, it'll show 1.79. And if we print line had coffee, it'll print line true. So, to recap, in this episode we learned that variables are used for storage. We can for now think of them as drawers in a large cabinet. Every time we make one, we need to give them a data type and a name. After that, we can assign values to this variable using the single equals sign. We also saw how we can use the printline function to see what is inside a variable. Now that we have storage, we can start to think about doing some basic math, which is exactly the topic of the next episode.